Good evening, everyone. We are pleased to present our technical competency project titled House Price Prediction. I am Sharat, along with my teammates Shriyari, Altaf, and Karthik. We have collaboratively worked on this project under the guidance of Malesh sir. Through this presentation, we aim to showcase how machine learning models can be utilized to predict house prices using the real-world data. Here, abstract. In this project, we focused on the predicting house prices using the Boston housing data, which is already known as dataset in the machine learning community. We compared two registration model, linear regression and decision tree regression, and used two performance metrics, that is mean squared error and mean absolute error, to evaluate their prediction accuracy. And our results show the decision tree model performed better than linear regression and highlighting its capability to capture complex and non-linear patterns in data. These are the abstract and introduction. In introduction, the dataset is used to the Boston housing data, which contains 506 data entries with the 14 features, and such as example crime rate, number of rooms, and property tax. The target variable is dataset in the median value of owner occupied homes measured in thousands of dollars, and predicting houses prices accurately in crucial in the real estate industry as it supports better investment decisions and urban planning and then market analysis. With the help of machine learning models, we aim to automate this prediction process and enhance its accuracy compared to traditional methods. And these are the introduction. And my friend Altaf will going to explain objectives of the project.
Thank you, Sharat. Now I'm going to discuss about objective of the project. The main objective of the project chosen by us is to design and evaluate two predicted models. The project uses two models which are linear regression and decision tree regression. It is used to predict the median value of homes in a data set. The main objective of the project is linear regression and decision tree regression. These models are assessed based on how well they predict the median value of homes. The outcome of the prediction will be the model with the lower mean square error and mean absolutely error is considered more accurate. The project aims to identify the more accurate model by comparing performance metrics like MCA and MAE, like as I said before. Another goal is to provide visual understanding of the prediction result. Predicted versus actual plots show how closely prediction match real values, and reschedule plots show errors and detect biases and variances. And decision tree diagram helps us to interrupt how decisions are made. Overall, the focus is on model accuracy, efficiency, and interpretability. The outcome of this project will be model performs better in terms of accuracy and error metrics, which is more efficient for real world use. Now I am going to discuss a problem statement related to our project. A problem statement, the predicting house prices involves many factors making manual prediction complex and unreliable. Predicting house price can be more challenging, means predicting complex and unreality prices. Traditional method often fail to capture relationship between variables. Traditional methods can often be complex. The challenge is to build a model that accurately estimates house price based on a multiple futures. The main challenge is to build an accurate model which will help us to determine the exact price by comparing multiple futures. This project addresses the problem by using machine learning techniques that can handle both linear and non-linear data relationships. The ultimate goal is to enhance decision making in house marketing. The main goal of the project is to enhance the decision making in the house marketing and give accurate price according to the market price. Thank you. Now my friend will Shreyar will continue.
Thank you, Altaf. Thank you, Altaf. Feature overview. In this feature overview, characteristics of houses in Boston area that used to specific predict the prices. Think of different pieces of information about house surrounding. House surrounding like house with high RAM, many rooms may be more expensive, and areas with low crime rate might also higher the housing prices. This is the futures of CRIM, ZN, and promotion of non-retail business across CHAS, NOx, RAM, Age, and DISRAD. Next, methodology. Firstly, she did load the data set of Baston House data. In the processing begins the loading the Baston House housing data set and move the data pre-processing and handling the missing the values and convert the data frame and if next one split data into train test. The data set is split into training of 80% and testing the 20% of sets. And next is train models. There are two aggression models of training data, linear regression and decision tree regression. And model prediction Model prediction is the trained models are used to predict house price on the text data, evaluate the performance, evaluate the performance. The performance both models evaluate the using models MSC and MAE, mean square error and mean absolute error, and finally getting the result of visualized the result using the scatter plots. Next, my friend Karthik is continuing.
Hello friends, I am Karthik. I am explaining applications. Real estate platforms, it helps to buyers and sellers estimate the fair market prices based on locations, numbers of rooms, etc. Urban planning assists the government in understanding housing trends and planning the infrastructures. Financial institutions used by buying and legenders to assist property value before providing loans or mortgages. Investment analysis, investors use a predictive pricing to evaluate a properties portfolios. Educational purpose demonstrates machine learning application using real world data set. Boston housing. Next is conclusion. This in this project we implemented and compared linear regressions and decision trees regressor model to predict the house price using the Boston housing data set. Both models were evaluated using mean squared error and mean absolute error matrix. The decision tree regressor achieved lower error values. ME is 10.42 and MAE is 2.39 compared to linear regression. However, it is important to note that decision trees can be prone to overfitting. Ultimately, while the decision trees performs better for this dataset, model choice should be also consider interpretability, simplicity, and real-world constraints. Uh, Thank you. Share the output.
Here we can see the implementation of the code. And as you know, already said, we are using Boston housing dataset with the implementation. And here, these are the imported required libraries to the Python. And this is the loading the dataset with the explore features. And then step two, in the step two, split into training the dataset and testing dataset. And in step three, we have fitting the linear regression model, and in step four, predicting the linear regression. And fifth one, fitting the decision tree and decision tree regression. And these are the regression we can evaluate using the MSC and MAE values, and then plotting the prediction with versus actual values. And here the graph which is showing linear regression and decision tree difference between. And here the we can give the input, that is crime per rate capita and the proportion of residential land zoned, and these are the input we have given the values. And the output is shown by the linear regression prediction, that is $29,133. This is the and linear prediction, and the decision tree prediction with that is given by $33,400, which is given by the that implementation. As I said before, this is the implementation code. And here you can see the output, which is given by linear regression, that is $29,133, and decision tree prediction, that is given $33,400. Thank you.